So part B for a fluids project. So we use the same geometry as we did for part A, except for we put a circle in the middle. And to create a circle, you go into geometry, create a circle in the center, and then you change the diameter to 40 millimeters, which is 1/10 of the height. So now we're in mesh, and we go to mesh, right click, insert method. In method, go triangle method, change this to triangles, then we generate. Then in mesh, we change the element size to 0.004, then we generate. And then after that, we go mesh, right click, insert, inflation. So we go to inflation. And then we change this, we make that no. We change the edge to the circle edge in the middle, the face geometry of this face. And then that's it. And then you generate. Then you go to edge sizing, which is mesh, right click, edge sizing, or just sizing, edge sizing. Edge is your circle wall, this circle wall right there. And then you change the number of divisions to 500 and change the behavior to hard. And then you generate. And then this is what the mesh should look like when you're done. Look like a black hole. And then after you do that, you do name selections, change it to edge, click, right click, go to name selections, and then change the name to inlet. You do that for inlet and outlet on this side. And then to change or to name the walls, you do the same thing, but you hold the control button on your keyboard while you do this side, this side, this side, and the bottom ones. And then you change it to walls. And then for the cylinder wall, you click on the cylinder wall, right click, create name selections, and change it to cylinder wall. And then you're done. And then you go mesh, right click, update, and then you go into your setup. So now that we're in the setup, same thing as the first one. Energy, double click, energy on, viscous, double click, K epsilon, standard, enhanced wall treatment, pressure gradient effect, thermal effect. Okay, cancel. Then we're going to go into materials, make sure that your fluid is air. So it should be air, and then these are all the same, changing create and close. Then we double check it was air, so we go into cell zone conditions, and then air, apply, close, boundary conditions. We go to inlet, double click inlet, it's the only thing we're changing. We're going to change it to our velocity magnitude, which we calculated. Apply, close. Outlet. And these should all be the same. And these cylinder walls should be stationary. And then when you're done with that, you go to report definitions, create, you do new, force report, drag. And then it's going to be drag force. And then you close. And then you go into the file reports. And then do print to console. Okay. And then we're going to go to initialization, initialize, run calculations, change the iterations to 150, calculate. Then when that's done iterating and calculating, we go into contours, right click, or we double click contours. We change it to pressure, static pressure, and then we select all of these by holding the control button on your keyboard and then save display. And it should, oops, this is what static pressure should look like if it loads. So this is static pressure. You can see it on the graph. If you zoom in where the cylinder is right there. Contour 2, velocity, magnitude, select all, save display. This is what our velocity magnitude looks like. Then we go to contour 3, save display, close. This is what our dynamic pressure looks like when you zoom in. And then if you want to change your legend, then you go to float to make it better. And then what I did for all these was I just went to snipping tool, new, snap. And I did that for all of them. And then we did XY plots. So we did this one, and then we looked at these XY plots for this is our dynamic pressure for our cylinder wall. We don't need that. This pressure coefficient, this is what it should look like, should be one line. And then you go into XY plot. Oh, that was the same thing. And then you're going to export the data. But for XY plot, you have to change it to static pressure. And then write to file, right? Click where you want it, put your name in, and then click OK. And then go into your folder, find it, then go and plot it into Excel. This is going to be your X position, your static pressure, and then this is your pressure coefficient, and then this is your X position and pressure coefficient. This is what the graph should look like at the end. And then to get the drag coefficient, we go back to where we were just now. Then we're going to go to our report plot we created, drag force. Not that one, the other one. Report definitions, double click, compute, and then your numbers should show up right there. And then you plug it into your formula. Drag force over 1/2 rho v squared times your diameter of your circle. And then that is your drag coefficient that you get. And that's all we have to do for part B.